For as long as humans have gazed at the stars, we have wondered, how far could a civilization truly advance? Could we one day harness the power of an entire planet, a star, or even an entire galaxy? If the cosmos is as vast and ancient as we believe, then surely, out there among the billions of stars, there must be civilizations that have already done so. And yet, as we scan the skies, we are met with a deafening silence. Where are they? The answer to these questions may lie in a bold framework proposed nearly 60 years ago by a Soviet astrophysicist, Nikolai Kardashev. Unlike previous attempts to classify civilizations based on culture, technology, or political structures, Kardashev proposed something far more fundamental: energy consumption. The reasoning was simple. Every civilization is bound by the laws of physics, and the amount of energy it can harness directly determines its technological capabilities, the reach of its influence, and even its long-term survival. Energy is the lifeblood of progress, and those who master it unlock ever greater possibilities. But what exactly does energy mastery mean in this context? It's not just about having electricity or advanced technology, but it's about the total amount of energy a civilization can access and control, measured in watts, just like the power used in light bulbs or computers, but on a planetary or even cosmic scale. Kardashev theorized that civilizations could be categorized based on their ability to harness increasingly vast amounts of power, moving through distinct levels of advancement. The more energy a civilization controls, the more ambitious its technologies become, from reshaping its planet to manipulating entire solar systems. Yet Kardashev's motivations went beyond theoretical classification. He was deeply involved in the search for extraterrestrial intelligence, or SETI, and he designed the scale not just as a thought experiment, but as a practical tool to help scientists detect signs of alien supercivilizations. The idea was straightforward. If an advanced extraterrestrial society existed, it wouldn't be hiding in the dark. It would be consuming energy on such an immense scale that it would leave behind observable traces, such as waste heat or artificial signals detectable across the cosmos. Kardashev wasn't just speculating about alien intelligence. He was actively searching for it. And for a brief moment, he thought he had found it. In 1963, a Soviet radio telescope detected an unusual signal coming from a quasar called CTA 102. At first, Kardashev and his colleagues believed this could be the work of an advanced extraterrestrial civilization broadcasting across interstellar distances. The excitement, however, was short-lived. Further study revealed the signal was of natural origin, a fluctuation in the quasar's emissions rather than an artificial transmission. While it wasn't evidence of alien intelligence, the framework he had created lived on. Today, the Kardashev scale remains one of the most widely used theoretical models for understanding civilizational progress, and its implications extend far beyond its original purpose. Yet, for all its fame, the scale has one glaring problem. Humanity hasn't even reached the first step. According to Kardashev's classification, a Type 1 civilization is one that has harnessed all the available energy on its home planet, mastering everything from solar and wind power to nuclear fusion and geothermal energy. Humanity, despite its vast technological progress, is estimated to be at approximately 0, 72 on the scale, meaning we consume only a fraction of our planet's full energy potential. But what does that number 0, 72, actually mean? It's not an arbitrary label. Physicist Carl Sagan refined the Kardashev scale into a continuous function, replacing its rigid step-based structure with a logarithmic equation that calculates a civilization's status based on its actual energy output. The equation considers both the total energy a civilization consumes and the theoretical maximum it could access. By this metric, humanity is far from planetary mastery, still limited in our ability to harness and control energy at a global scale. This limitation is more than just a theoretical classification. It has real-world consequences. We remain at the mercy of natural disasters, unable to fully prevent earthquakes, hurricanes, or climate shifts. A true Type 1 civilization wouldn't just endure these forces. It would command them, redirecting hurricanes, stabilizing planetary temperatures, and even controlling seismic activity to prevent earthquakes. Energy would no longer be a scarce resource subject to economic and political constraints. It would be abundant, efficiently distributed, and virtually limitless. But this raises a troubling question. If the Kardashev scale is the roadmap to progress, why haven't we moved past this point? After centuries of technological advancement, why has humanity failed to reach even the first major threshold? And perhaps even more unsettling, if advanced civilizations exist, why aren't we seeing them? The sheer scale of the universe suggests that we should not be alone. If there are civilizations out there that have already traveled this path, shouldn't there be evidence? Dyson spheres encircling distant stars, megastructures dominating the night sky, or undeniable proof that someone somewhere has harnessed the power of entire planets, stars, or even galaxies. And yet, despite increasingly powerful telescopes, despite decades of searching, the cosmos remains eerily silent. If we are to truly understand the Kardashev scale, we must go deeper. What exactly are the steps that lie ahead? How do we move from a civilization still struggling with energy scarcity to one that commands entire solar systems? And if it is possible to reach such heights, why is the universe not teeming with the evidence of those who have done so? If humanity is still below Type 1, then what exactly lies ahead? The Kardashev scale outlines 3 key stages of civilizational development, each representing an exponential leap in power and technological capability. These classifications, Type 1, Type 2, and Type 3, describe the theoretical steps required to move from a planetary civilization to one that dominates the very fabric of the cosmos. A Type 1 civilization is one that has achieved total mastery over the energy resources of its home planet. This means utilizing solar, wind, geothermal, nuclear, and other energy sources to their maximum potential. A true planetary civilization would control its climate, manipulate weather systems at will, and prevent natural disasters before they happen. It would reshape landscapes, manage planetary resources without scarcity, and sustain an advanced, technologically driven society with limitless energy. But why does reaching Type 1 require global cooperation? Couldn't an authoritarian regime or a small faction of advanced nations lead the way without worldwide participation? In theory, a dominant power could initiate the transition, but the problem is scale. Planetary energy control requires planetary coordination. Climate engineering, large-scale energy redistribution, and planetary defenses against natural disasters all necessitate a degree of cooperation that transcends national borders. Without it, resource competition and energy inequality could prevent the transition. This raises another question. Could a civilization bypass Type 1 entirely and leap straight to Type 2? Could a species evolve in space without a home planet and build Dyson spheres directly without ever mastering planetary energy? In theory, it's possible, but unlikely. Civilization must first develop the technology to build a Dyson sphere, which requires a significant planetary infrastructure for mining, energy processing, and large-scale construction. A spacefaring species could, in theory, colonize multiple planets first, utilizing multiple energy sources before constructing stellar megastructures, but this would still require mastery of planetary energy at some stage. A Type 2 civilization doesn't just control its planet, it controls its entire star. Instead of merely utilizing solar power from a distance, a Type 2 civilization could build enormous megastructures like Dyson swarms to harness the full energy output of its sun. But if Dyson swarms are the next logical step, why haven't we detected even primitive versions of them? One answer is observational limitations. Most searches for Dyson spheres focus on infrared radiation, as these structures would inevitably leak waste heat. However, if an advanced civilization has found a way to recycle or obscure that heat, it might be nearly invisible to our current instruments. Then, there is Type 3, where the concept of civilization stretches to its absolute limits. A Type 3 civilization does not confine itself to a single star system, but dominates an entire galaxy. It would harness the energy of billions of stars, possibly by constructing networks of Dyson swarms across multiple systems, or even extracting power from black holes. But if such civilizations exist, why don't we see them? If the Kardashev scale is correct, then something is wrong. Either we are missing something in how we search for them, or civilizations do not evolve in the way we expect. And that brings us to an even bigger question. What if Kardashev was wrong? If a Type 3 civilization is the master of a galaxy, what could possibly come next? Kardashev's original model stopped at this stage, but many scientists and futurists have speculated on what might lie beyond. The leap from planetary control to interstellar dominance is vast. But is there a frontier even further than the stars? The Kardashev scale may not have all the answers, but it offers a tantalizing glimpse into what the future of intelligence could be. A Type 4 civilization would go beyond a single galaxy. It would manipulate energy at a universal scale, harnessing the power of multiple galaxies, possibly even tapping into dark energy, the mysterious force that is accelerating the universe's expansion. But is such a civilization even physically possible? Could an advanced species truly manipulate entire galactic clusters, or redirect the flow of cosmic structures? The laws of physics, as we currently understand them, do not rule this out, but the challenges would be extraordinary. Even if a species could extract energy from quasars or supermassive black holes, there is no known way to exert direct control over multiple galaxies at once. The distances involved are mind-boggling, with galaxies separated by millions of light-years, making any form of centralized control nearly impossible by known technological means. Theoretically, a civilization at this level might have developed the ability to harness gravitational waves or quantum entanglement on a vast scale, creating networks of energy transfer beyond our comprehension. Some have suggested that instead of expanding outward, a Type 4 civilization might choose to manipulate the very fabric of reality itself. Could they control fundamental forces like gravity, entropy, or even the nature of time? We already know that black holes emit Hawking radiation as they slowly evaporate. Could an advanced species harvest this energy? Some physicists have even speculated that extremely advanced civilizations might find ways to circumvent the second law of thermodynamics, gaining an infinite energy supply by reversing entropy. And then there is Type 5, a civilization that controls not just the physical universe, but the multiverse itself. If the multiverse hypothesis is correct, there could be an endless number of realities beyond our own. A Type 5 civilization might be capable of creating entire universes, manipulating the very fabric of existence to their liking. But if such entities exist, would they even be detectable? Would they have any interest in lower-order civilizations? If a Type 5 civilization had mastered reality, it would be indistinguishable from what some cultures might call gods. But that leads to an even more unsettling question. If such entities exist, and they are capable of creating or destroying universes, then who or what governs them? Do they exist in harmony, or is there a conflict among multiversal beings? If reality is something that can be engineered at will, then what is the true nature of existence? This also raises the issue of interaction with lower civilizations. If a Type 4 or V civilization exists, why would they ever bother interacting with us? This is one of the theories behind the zoo hypothesis. The idea that advanced civilizations might be deliberately avoiding us, allowing us to develop naturally without interference. Some scientists argue that a civilization at this level might have transitioned into an existence beyond our ability to perceive, operating on dimensions or frequencies that human instruments cannot detect. But there's another theory that suggests we may not be looking in the right way. If civilizations at this level have transcended the need for physical expansion, they may no longer rely on massive energy consumption to signify their existence. A truly advanced society might exist as pure information embedded in the quantum structure of reality itself. This challenges the very foundation of the Kardashev scale. If energy consumption is not the true measure of progress, then what is? And this brings us to an alternative way of thinking. Perhaps the greatest civilizations are not those that conquer galaxies, but those that master control at the smallest possible scales. The Kardashev scale assumes that energy is the primary driver of advancement, but what if we've been thinking about this all wrong? Several scientists have suggested that rather than focusing on bigger and bigger energy sources, true civilizational progress may actually be about going smaller. Instead of constructing megastructures to harness entire stars, what if the most advanced civilizations operate at a level invisible to the naked eye? This is where the Barrow scale comes in, proposed by astrophysicist John D. Barrow. This model doesn't rank civilizations by how much energy they consume, but by how much control they exert at the smallest possible levels. Instead of harnessing stars and galaxies, a Barrow-scale civilization might be manipulating atoms, molecules, or even the fundamental laws of physics at a quantum level. Consider this. Humans already edit DNA, create nanotechnology, and simulate entire realities in computers. What if the most advanced civilizations aren't expanding outward but inward? Could intelligence eventually abandon physical form altogether, existing purely as digital or quantum consciousness? If a species achieves perfect control over its environment at a microscopic level, it may have no need for expansion or conquest. But has the Barrow scale been tested or accepted in academic circles? While it remains a theoretical model, it has gained traction among some physicists and futurists who argue that the Kardashev scale is too simplistic. However, there is no direct observational evidence supporting either model. Both remain speculative frameworks for now. Another alternative model comes from Robert Zubrin, who suggests a more exploration-based classification. Instead of measuring a civilization's technological prowess in terms of energy, Zubrin's model categorizes civilizations based on how far they have expanded, first dominating their home world, then their solar system, and eventually interstellar space. According to this model, a civilization's success is measured not by how much power it consumes, but by how well it navigates and thrives within its cosmic environment. But could civilizations transition between different classification models? Could a species begin as a Kardashev-style civilization, only to later shift toward a Barrow-style civilization? If a species achieves total mastery over its own biology and consciousness, does it even need to reach type 2 or 3? This also challenges the assumption that civilizations evolve in a linear fashion. Some theorists argue that intelligence doesn't necessarily trend toward interstellar expansion. What if civilizations that develop AI, virtual existence, or total quantum control choose not to expand outward at all? Some might simply turn inward, living in simulated realities that require minimal energy consumption. And if that's the case, then maybe the Kardashev scale is not a roadmap, but rather a single perspective. One way of looking at civilization's potential, but not the only way. This raises another urgent question. If advancing through the Kardashev scale is even possible, why haven't we done it yet? What obstacles stand in the way of reaching Type 1, let alone anything beyond? And even more disturbingly, what if something is stopping every civilization from progressing past a certain point? That's where we turn next. To the great filter, existential threats, and the terrifying possibility that the silence of the cosmos is not a mystery but a warning. If civilizations can theoretically ascend from planetary to stellar and even galactic dominance, why haven't we seen any evidence of them? Why is the universe so silent? The answer may lie in something far more ominous than simple distance or lack of technology. The Great Filter is a hypothesis that suggests there is a nearly insurmountable barrier preventing civilizations from advancing past a certain point. The silence of the cosmos might not be due to the absence of intelligent life, but rather a consequence of a brutal cosmic truth. Most civilizations don't survive long enough to reach Type 1, let alone Type 2 or 3. But where exactly does the Great Filter lie? There are two possibilities, and one of them should terrify us. One possibility is that the Great Filter is behind us, meaning that intelligent life itself is exceedingly rare. Perhaps the emergence of biological organisms capable of intelligence is an almost impossible event, and we humans are among the lucky few who made it. If that's the case, we might be alone in the galaxy, but at least the future remains open to us. The second possibility is far worse. The great filter is ahead of us. This would mean that civilizations tend to self-destruct before ever reaching Type 1 or 2. And when we examine our own trajectory, this seems disturbingly plausible. Every time humanity has made a great leap forward in technology, we have also created existential risks that could wipe us out. Nuclear war, climate change, artificial intelligence, biotechnological pandemics. These are not just hypothetical dangers. They exist right now, in our own time. The physicist Michio Kaku has warned that transitioning to a Type 1 civilization is the most dangerous phase of our development. Why? Because reaching Type 1 requires complete planetary cooperation, technological mastery, and careful management of energy and resources. The very tools that could propel us forward. Advanced nuclear energy, artificial intelligence, genetic modification, could also spell our doom. But it's not just self-destruction that could be the great filter. There's another, even more unsettling theory. What if something out there is eliminating civilizations before they reach the stars? And some researchers have suggested that the reason we don't see Type 2 or 3 civilizations is that something or someone is ensuring that they never get that far. This idea, often called the dark forest hypothesis, is based on a chilling assumption. In a universe where civilizations are competing for resources, the safest course of action is to remain silent and hidden. A young civilization like humanity, broadcasting radio waves into space and actively searching for extraterrestrial intelligence, may be like a newborn animal crying out in the night, unaware of the predators that may be listening. If an advanced civilization detects another, it may see it as a potential threat and preemptively destroy it before it can become a rival. If this hypothesis is correct, then perhaps civilizations don't go extinct by accident. They are eliminated before they reach Type 2. But there's another alternative. What if civilizations don't expand because they don't need to? What if the most advanced societies are not the ones that conquer the stars, but those that withdraw from physical reality entirely? Some theorists suggest that truly advanced societies may not pursue large-scale energy consumption at all. Instead of spreading outward, they might turn inward, focusing on quantum computing, digital existence, or even uploading consciousness into synthetic substrates. In this scenario, a civilization's greatest achievement isn't starships and megastructures. It's the ability to exist outside of traditional physics entirely. If a species achieves total mastery over virtual existence, simulated realities, or quantum consciousness, then it may not need to expand beyond its own self-sustaining world. If that's true, then perhaps the answer to the Fermi paradox, the question of why we haven't encountered advanced civilizations, is brutally simple. They are here, but we are not advanced enough to recognize them. This raises an urgent question. If we're to survive, how do we avoid becoming just another casualty of the great filter, say? Is there a way to break through, or is our fate already sealed? That's where we turn next. To the challenges of advancing to Type 1, the global effort required to escape the fate that may have doomed countless civilizations before us, and the question of whether we are running out of time. So where exactly do we stand on the Kardashev scale? Physicists estimate that humanity is currently at approximately 0.72, far from planetary mastery, but no longer a primitive civilization. The transition to Type 1 means harnessing all the available energy on Earth, solar, wind, geothermal, nuclear, without destroying ourselves in the process. The good news is we're making progress. The shift towards renewable energy, nuclear fusion research, and global technological collaboration are all signs that we are inching closer to becoming a true planetary civilization. Scientists predict that at our current rate of energy consumption growth, about 3% per year, humanity could reach Type 1 within 100 to 200 years. But why do we measure progress in percentage growth instead of raw energy figures? Unlike simple energy output, percentage-based growth reflects long-term trends and technological efficiency improvements. A 3% annual increase, if sustained, leads to an exponential rise in total energy consumption over time. However, this growth is not guaranteed. Economic collapses, wars or environmental disasters could slow or reverse it. But the challenges of reaching Type 1 go beyond just energy. Planetary cooperation, technological stability, and social evolution are just as important as scientific breakthroughs. Right now, humanity is deeply divided. Geopolitical conflicts, economic inequalities, environmental degradation, all of these threaten to derail progress toward Type 1. The rise of nationalism, resource scarcity, and technological misuse could push us into global instability rather than planetary unity. Could artificial intelligence play a role in managing planetary energy? Instead of being a risk, AI could be used to optimize energy use, prevent shortages, and regulate energy distribution. A self-learning AI system could manage global grids, maximizing energy efficiency while minimizing environmental impact. But it could also become a threat if misused. AI governance over planetary energy might lead to an unprecedented concentration of power. And what about the governance structure of a Type 1 civilization? Could such an advanced world be ruled by separate nations, or would reaching Type 1 necessitate a global government? Managing planetary energy efficiently and fairly might require some form of unified global infrastructure, but would that mean the loss of national identities? Would energy be controlled by a single authority or decentralized systems? Then there's the question of timeframes. If we are 100 to 200 years from Type 1, how long would it take to reach Type 2? Could we get there in a few centuries, or would it take millennia? Is interstellar energy dominance even possible within the lifespan of our species? And here's another disturbing thought. Could a civilization remain stuck at Type 1 for thousands of years? The Kardashev Scale assumes that advancement is inevitable, but what if cultural stagnation, technological plateauing, or internal conflicts prevent further progress? If civilizations can remain trapped at a single level, then the Kardashev Scale may be less of a ladder and more of a spectrum, a framework in which civilizations rise, fall, or even abandon progress entirely. The key question remains, will we succeed? Or will humanity remain stuck at 0.72, forever on the precipice of greatness but never quite stepping forward? That is a question only history will answer. But if we do break through, if we do reach Type 1, then we will have taken the first true step towards something even greater. And that brings us to our final question. What happens next? If we conquer our world, do we stop there? Or do we set our sights on the stars? If we do, what challenges lie ahead for a civilization striving to become truly interstellar? And most importantly, is there anyone already out there waiting for us? If humanity succeeds in overcoming its challenges and reaches Type 1 status, what happens next? Do we consolidate our dominance over Earth and remain a planetary species indefinitely? Or do we set our sights on the stars? The Kardashev Scale suggests that the natural progression is toward Type 2, where a civilization harnesses the full energy output of its star. But is this transition inevitable? Could a civilization achieve Type 1 and decide that further expansion isn't necessary, or even desirable? Assuming we do continue advancing, a Type 2 civilization would have mastered the art of stellar engineering, extracting nearly all of the energy emitted by its sun. This wouldn't just mean solar panels or fusion reactors. It would require colossal megastructures capable of intercepting and storing vast amounts of solar energy. The most well-known theoretical construct for this is the Dyson Sphere, first proposed by physicist Freeman Dyson. A Dyson sphere would surround a star, capturing its entire energy output and supplying an interplanetary civilization with limitless power. But is such a structure even realistic? Some astrophysicists argue that a solid Dyson sphere is fundamentally unstable and that it would collapse due to gravitational and structural stresses. Instead, a more viable alternative could be a Dyson swarm, a vast collection of orbiting satellites that absorb and transfer energy back to the civilization. If such structures exist elsewhere in the galaxy, they should theoretically be detectable by their heat signatures, emitting large amounts of infrared radiation. This has led to projects like the Breakthrough Listen initiative, which scans the skies for signs of extraterrestrial megastructures. But so far, no definitive evidence has been found. Could it be that we're not looking in the right way? If an advanced civilization had found a way to recycle or obscure waste heat, they might be nearly invisible to our instruments. A Type 2 civilization wouldn't just harvest a star's energy. It might also move planets, terraform hostile worlds, and even control the weather of entire solar systems. The ability to manipulate planetary orbits could allow such a civilization to adjust its homeworld's position relative to its star, extending its habitability indefinitely. Some scientists speculate that an advanced species might even redirect asteroids and comets, using them for raw materials or reshaping their planetary environment as needed. But here's a question few consider. Could a civilization be stuck at Type 1 for thousands of years? The Kardashev Scale assumes that once a species masters planetary energy, it will naturally progress towards stellar energy. But what if this assumption is wrong? A Type 1 civilization might never need to expand. If energy efficiency reaches near perfection, if planetary resources are managed flawlessly, and if social or political structures favor stability over exploration, then there might be no incentive to take the leap to Type 2. Could a society that achieves true equilibrium, perfectly sustainable, technologically advanced and self-sufficient, choose to never go beyond its own world? Yet if we do push forward, reaching Type 2 would mean expanding beyond Earth and into the solar system as a whole. Colonization of Mars, mining asteroids for resources, and establishing bases on the moons of Jupiter and Saturn would be the first stepping stones toward interstellar civilization. Some futurists argue that humanity's long-term survival depends on becoming a multiplanetary species, ensuring that no single planetary disaster, natural or self-inflicted, could wipe us out completely. But expansion isn't just about survival. It's about unlocking the true potential of intelligence in the cosmos. The Kardashev Scale implies that an advanced species wouldn't stop at its home star. Eventually, a civilization that dominates one solar system may seek to expand to others, leading us toward Type 3, a stage that involves the colonization and control of an entire galaxy. Yet there's a problem. The universe is vast, and even with the best propulsion technologies we can imagine today, interstellar travel remains extraordinarily difficult. This is where the biggest obstacle to reaching Type 3 emerges: the sheer scale of space itself. If Type 2 civilization is achievable, then Type 3 should be the logical next step. But how realistic is it for a species to spread across an entire galaxy? And if it's possible, why haven't we seen any evidence of civilizations that have already done so? A Type 3 civilization would have access to the energy of billions of stars, possibly through vast networks of Dyson swarms, or even more advanced means, such as extracting energy from black holes. Some physicists have theorized that a civilization at this level might harness energy from quasars, the supermassive black holes at the centers of galaxies, tapping into their immense gravitational power. Others have speculated that dark energy, the mysterious force driving the expansion of the universe, could one day be controlled by an advanced species, opening the door to unimaginable possibilities. But how would a civilization even get to this point? Interstellar travel remains one of the biggest challenges in physics. The vast distances between stars make conventional travel nearly impossible, at least with current human technology. Our fastest spacecraft today, like the Parker Solar Probe, travel at speeds of around 430,000 miles per hour. At that speed, it would take over 17,000 years to reach the nearest star system, Alpha Centauri. For a civilization to spread across a galaxy, it would need propulsion technologies far beyond anything we currently possess. Scientists have proposed several possibilities, including nuclear fusion rockets, antimatter propulsion, and even light sails pushed by laser beams. But the most exotic idea is the use of wormholes or warp drives, bending space-time itself to allow for faster-than-light travel. Though highly theoretical, such concepts remain mathematically possible under Einstein's equations, and some physicists, including Miguel Alcubierre, have explored designs for a warp bubble that could theoretically allow for interstellar journeys without violating known physics. But even if faster-than-light travel is possible, it doesn't solve the Fermi paradox. If civilizations can expand across entire galaxies, why don't we see them? Some scientists argue that the answer is simple. Galactic empires might not be sustainable. The logistics of managing interstellar civilizations may be impossible due to time delays in communication, resource scarcity, and fundamental biological or social constraints. There's also the possibility that civilizations don't expand indefinitely. What if intelligence follows an entirely different path? One that doesn't require cosmic conquest? Some researchers believe that the most advanced civilizations might choose to retreat from the physical universe, existing instead in vast, self-sustaining virtual realities. Instead of spreading across the stars, a civilization might find infinite expansion within its own artificial worlds, requiring only minimal energy to sustain itself indefinitely. This idea leads to an even deeper question. What if the most advanced civilizations don't even exist in the forms we expect? If intelligence can evolve into purely digital or even quantum states, they may no longer interact with the physical universe at all. If this is the case, then perhaps the Kardashev scale itself is flawed. Maybe energy consumption is not the defining feature of progress. Maybe the most successful civilizations aren't those that consume the most power, but those that learn how to minimize their energy footprint while maximizing their intelligence and influence. Perhaps the true measure of advancement isn't the ability to conquer galaxies, but the ability to shape reality itself, whether through energy, information, or consciousness. If that's the case, then humanity's future may not be about reaching Type 3 at all. It may be about redefining what it means to advance in the first place. Whether we are alone in the cosmos or merely blind to what exists, our fate remains unwritten and the greatest discoveries may still lie ahead.